Okay, good morning all, and welcome to Spatial's webinar series for FME. This morning we're looking at tuning FME for speedy data processing. Thanks for joining us. My name's David Eagle from Spatial, and we'll get right into it now. So the things that we're going to look at today focus around performance tuning. The reason why we're looking at performance tuning is because it's something that myself and colleagues get frequently asked about, how to make your FME processes go quicker, be more performant and be more scalable. So we're going to give you a few tips for how you can adjust your processes, what you can do and what information you can glean from the log file, what methods you can deploy to debug your processes. We'll look at particular transformer parameters that you can use to really help move your data flow to flow through them in a much more efficient way. Your use of attributes and whether you need to keep them, and how you might remove the content that is unnecessary in your target schema. And we're going to look at the ordering of both readers and writers in your navigation pane, because believe it or not, the order of your readers and writers makes a real big difference to the efficiency of your process. Spatial are a platinum partner of Safe Software. We have a number of different offices globally, and we offer a number of different services around several different technologies. The focus of this session is around Safe Software's FME product, but we have a core business that focuses around national mapping agencies as well. So that's a very brief overview of ourselves. We've been around for a good while. 1969 was our birthday. So over 45 years of development in the GI arena, and that's where we are. You can see from this slide here briefly that the FME product comes in three main flavors: FME Desktop, FME Server and FME Cloud, where FME Server is the way of running the FME engine through a web browser and through a scalable solution. FME Cloud is effectively FME Server run in a cloud environment, in this case an Amazon hosted environment. Initially though, we really are going to be focusing in this session on the FME Desktop product, because ultimately if you author a process in FME Desktop, if you make it as efficient as possible, then when you port that to FME Server or FME Cloud, you're in the best position you can be. So we're going to focus our attention in that arena. We have a number of certified FME staff around the world, both FME professionals and trainers. These are accreditations that we have to work to get, and we get accreditation for up to 3 years. I have both of these accreditations. We have dedicated technical support staff, and any of our FME customers have access to free technical support through our support team. So if you buy your FME from us, then you have access to that service. We do lots of things, including consultancy and training as well though. So if you want to find out more about what we're covering on this topic today, we do a lot of focus sessions for customers around the FME technology stack. So then, one of the reasons for doing this webinar is I was inspired to deliver this this session based on a blog posting that Mark Island put up recently. Mark is the FME evangelist, and many of you will know his blog postings and see the level of detail that he puts in place in those documents. They're extremely helpful, and if you want to follow him on Twitter, there's his Twitter handle. He's based out in Canada. He works directly for Safe Software, and His performance session that he did recently, the blog posting, is effectively what I'm using as my basis for discussion here. I'll show you the workspace that he used in his article and show you some of the impact of the changes that he's made to that workspace throughout the document. If you want to go and have a look at that article, it's article 147. If I just pop this open in the browser, you can see it. And you can see that he listed a very useful and a very strong discussion around some of the technology that you can put in place. I know though that some of you prefer to see things in action rather than necessarily read the detail, so that's partly why I'm delivering this session today. There are some companion webinars that you can go and look at as well. If you have a look at our YouTube channel on youtube.com/one-spatial group, there is a little friendly URL
Actually,
there.
pause that at that point.
Get rid of my voice again. You don't want to hear it in stereo. Tips for performance tweaking your processes. So this is an article that would be pretty handy for you to go and look at, and it focuses more around the technology and temporary files and system resources and that kind of thing. So a useful session to go and look at. There is also another session that I joined in on, hosted by Safe Software, which was a turbocharging session, and that was with both Mark himself and Dale Lutz. So that's also worth going and look at. Safe Software's YouTube channel is /FME channel. So One Spatial Group or FME channel are the two YouTube channels to take a look at. So now we've got the sort of background out of the way, let's go and have a look at some of the things that you can do. And we're going to do that in conjunction with an FME workspace. So here's a process that we're going to have a look at. And let's just unpick what's going on first of all before we get into the detail of it. So I'm looking at this in FME 2016.1. So that's the latest release of FME. It was launched officially at the end of last week. So worth going and getting from safe.com/downloads is the place you can get the latest build if you're on an annual maintenance contract. And you can see in here that we have a couple of readers and a couple of writers. So the first reader here is a CSV. We'll go and have a look at what's in this file. These are mobile phone towers, the locations of those stored in a CSV. So there is no geometry in this case. I'm just going to read in that data, just have a quick look at it. I've not defined how I want to read it. I just want to throw it over to the inspector and have a quick look at that quickly. So we'll let that render there while that's coming in. So as you can see, there's quite a lot of data in that file. There is also a neighborhood data set. So if we go and look at this one, this is stored in KML. These are neighborhood boundaries. So we can see that we've got our neighborhood locations. Let those appear. While we do that, let's just have a look at the containing folder. I want to prove that there's no geometry in this file, but you'll see something clever that the inspector has done behind the scenes. So we'll pop that open in Excel, and you can see that in this file there is a latitude and longitude column. The latitude and longitude is the location of the tower, and the important things are that this indicates the strength of the signal from that location. So there's quite a few records in here, something like 15,000 odd records, sorry, 150,000 in fact, records in there. So rather a large data set. What we can see in the inspector, if we just pop that back up, is there's the neighborhood boundaries. And if we go back to the previous view, what's happened is that the inspector has identified that there is a column called longitude and latitude, and it's automatically generated the geometry for those locations. So you'll see that there's a lot of cell signal locations here. So these are the locations that each of the towers have been monitored. So that's all our information that's coming back for those cell towers. So the workspace takes all of those CSV records, and there's a bit of an odd thing that goes on at the front here, and it's really so that you can see the magnitude of the difference when we work with a large volume of data. So what's happening here is pushing the data into a cloner, and we're cloning this cell tower information 10 times per feature. And that's so that we can see a big difference in the performance that this process gets as we edit it. So you can sort of pretend that that transformer doesn't exist for the sake of this exercise. What we do is we take the cell tower information and we clip it against the neighbourhood boundary in order to find out which boundaries are containing the cell towers. The cell tower signal information comes out of here. Now knowing which neighbourhood it's in. The benefit to that is that the idea is we want to identify where there are weak signals and go to those locations and see what we can do to solve it. So if we then test the power, we want anything that's less than 125 in strength, in power. We're going to send that off to this cold spots layer and understand which neighbourhood those poor signals are going to be received in. And anything that is alright, is an okay signal, then we'll send it to this good locations file. And in this case, we're writing that out to a shapefile, and we're sending off to a shapefile on the cold spots as well. So that's the process in a little bit of detail. What we'd like to do is go and understand a bit of information about how long this takes to run. And we've got a couple of things we can look at, and an interesting comparison is that Mark Island ran it on his machine and I've run it on my machine, and the difference is quite marked. So let's go and have a look at Mark's log file, his process. So you can see that we can identify quite quickly from the log that he's using an early build of FME 2016, and it is the 32-bit build. So that's interesting to be aware of. We can also see that on Mark's system he is using a 64-bit operating system. So the suggestion is that there could be a performance gain that Mark could get by going and using 64-bit FME on a 64-bit platform. So if you go to safe.com/downloads, you'll see that there is a 32-bit and a 64-bit build of FME to download. One thing to be aware of is that as yet the 64-bit build doesn't have quite as many formats that the 32-bit does, and part of that is down to the formats being dealt with by Safe and getting them up onto the 64-bit platform, and part of it is that those formats and those environments they're writing to are not supported in 64-bit. So if I just go to that URL, safe.com/formats, one thing to go and take a look at is whether the format you care about is actually supported on the 64-bit platform. So if we just dive over to that page here, you can see if you swap to platforms, you can go and have a look. So if we go and look for personal geodatabase, for example, you can see that it's only supported to be read and written on the 32-bit Windows platform. So a couple of things to be aware of there. So Mark could perhaps get a bit of benefit here by putting a 64-bit installer of FME on his machine, and bear in mind that you can install 32-bit and 64-bit on the same platform, assuming you've got a 64-bit operating system, and you can use those with the same license, so that's fine. If we dig around, we can see that he's got plenty of temporary space in his temporary folder, so that shouldn't be an issue for his process. And he's got plenty of RAM available, so 24 gig of RAM. So he's got quite a powerful machine, and he's got some virtual memory tucked away in here. There it is, plenty of virtual memory defined as well. So he's in a fairly good position. This is the log file from the run of the workspace with no editing to it. And if we scroll all the way down to the bottom, we can see there's a few things to see in here that are of interest. The first thing is that it only had one warning, so we might go and scroll up and go and find out what that warning is. It's not relevant to this process though, so we're more interested in how long it took to run, so about 11 minutes. Importantly though, we can see that the CPU time was 306.7 seconds. Now that's around about 5 minutes. So what that means is that whilst the machine itself was working quite hard for 5 minutes, the process took over 11 to run. So that suggests that some time is being lost somewhere, and that might be that there was temporary data being cached to disk because his process ran out of memory. But as he's got quite a lot of memory, it's more likely the fact that the operating system couldn't access that memory, so it's a 32-bit FME, so it couldn't access it. He's also got quite a high peak memory usage here. So ideally you want to try and keep this as low as possible for sustainability, because, for scalability. So there's a few things to be aware of. One of the interesting things as a comparison here is if I just go and open up the log file that I ran on my machine. So this is the same workspace on a different machine. This time I was using 64-bit FME, and I was using a much more recent version of FME desktop. And I've got a 64-bit operating system with 64-bit FME on it. And you can see that I've got a reasonable amount of RAM, though nothing like the volume that Mark has got access to. But if we scroll all the way to the bottom, you can see that on my laptop running the same process took 42 minutes. Now, part of the reason for that, I believe, is that I believe Mark's machine has a solid-state drive, and because both processes are running out of memory and having cache to disk, the speed at which that information comes back is not as quick as it could be. You can see here my CPU time is 440 seconds, which is around about 7 minutes of the 42 that it takes to run. So huge differences there just based on the hardware and the build of FME that we're using. So we need to go and unpick some of these discrepancies, because just changing the machine is clearly a challenge here. It's producing two slow processes. One is significantly slower than the other, so we need to unpick that a little bit. Oh, actually, there was one other thing that I need to mention, and that's this statement here: optimizing memory usage. Let's just go and reopen that log, because that's definitely something that we ought to look at. If I do a search in this log file for optimizing, and go and do a search for it. If you ever see this resource manager kicking in and telling you that memory usage is being optimized, that is not something you really want to see. That basically means that you have run out of physical RAM, and FME is trying its hardest to cache to virtual memory, to paging files. So at that point, you need to sort of consider your workspace design and then hardware afterwards. It's most likely that the way in which you're processing your data needs to be subtly adjusted to try and avoid getting this optimization message. So that's a key thing to look out for. Okay, so let's go and see how we can try and debug a process like this. The first thing I'd always say when it comes to looking at a workspace is how long is it actually taking you to read the data? So we know that this process takes 42 minutes to run to completion. So if we do multi-select and Control E, and actually I'm going to Control E after the cloner in this case, because we're forgetting that exists. So let's just disable that link there. So Control E disables all the transformers in this process, and we're going to hit run here, and it prompts and runs the process, and it's going to read in the source data. And we'll let that rattle through and read the content. And the key thing here is that where are we reading the data from? That sometimes makes a difference. If you're going over a network that's very constrained or has got a lot of traffic across it, it may take time to read that data. Or perhaps the disks that you're reading from have a slow spin speed, slower than is optimal at least. So we want to get that data rattling through into the workspace as quickly as possible. In this case, you can see that the features are racing in reasonably quickly, and they're arriving in the transformers. And we want to understand how long that runtime is out of our 42 minutes. So we'll let that just get on with it. I don't believe it runs for very long, but we'll soon find out. I might just tuck it off screen for a moment, just while we have a look. So the key thing is that you disable all the transformers after the read process, and that's actually just completing, so I'm going to bring that back in. There you go. So it took it just over a minute to read all the data. So we know it takes 42 minutes to process, but it takes a minute to read the data. So clearly the effort is not involved in the data read. If you were reading from a database, you would want to take a look at whether there were appropriate indexes applied on your incoming data as well, because that can affect the performance of the read in some cases, especially if you're reading the data using SQL queries or where clauses on your data read. So the other thing to look out for is dangling readers. Now that's a bit of an odd term, so let's go and have a look at what we mean. Those of you with a keen eye will notice that there are a whole bunch of feature types here on the canvas that are not connected to something, and we often see this in our support cases where maybe a data set has got more layers in it that you care about in your process, but you sort of tuck these away because you think, well, maybe one day I might use them, and one day I might connect this in and do something to it. Well, if that day arrives, then's the time to add the feature type onto the canvas, because what you might not realize is that this data is being read. It's then being thrown away immediately. So that's quite an overhead. So if you put a feature type on the canvas and you leave it available here, then the data's being read. So the key thing is that you either select these things and hit the delete key, or if you go to the tools drop down menu, you can remove the unattached feature types. Gives you a list of all the ones that you want to get rid of, and then you can do that straight away. I'm going to bring these components back in, and it makes, apart from anything, it makes this workspace a little bit easier to look at as well. So, so that's the main thing to be aware of on the reader side, to avoid having those dangling readers. So, what else have we got in here? Well, the other thing and the other place to look, we've looked at readers. Well, what about the writers? Mark Ireland has put a few, actually quite a while ago, he did a good blog posting on the order of readers and writers in your workflow. So go and see if you can have a look at that article in the Safe blog. But writer performance makes a big difference, and let's just have a look at what I mean by that. So this is the task manager from my machine when I ran this process, and running it in its standard state without doing any edits to it, you can see that as I kicked it off, the RAM was just a straight line. The CPU side of things is pretty much irrelevant here. So the RAM was a straight line. The only reason it drops off here is because in order to take the screen grab, I had to actually kill the FME process, because pretty much my machine became unresponsive because of the heavy load that this process was having on my machine. Just by making one minor tweak to the process, it went into reverse. So effectively, when I ran the process, it started releasing memory very quickly. And that's the kind of thing that you want to see if you are going to scale your process to deal with hundreds and thousands of records rather than just a few hundred, which is often the case when you build your workspaces initially. So let's go and have a look at what we mean here. So if I bring that workspace in, So in here, if I pop up my task manager, so I've got a few things running on my machine at the moment for this webinar, so it's not a completely clean process, but if I hit run here, and we go, and get the task manager back in front, what you should see is as soon as I kick it in to go, that RAM usage starts to go in a direction that is going to make me a bit nervous, especially if I know that this is just a sample data set. So this is a constant move, and you can also see that actually the data is only getting so far in the workflow. So any data that's getting to this point is effectively going into memory for the time being. So I'm going to stop that because we don't want to sit here and watch 42 minutes of a log file scrolling by. You see that the memory is immediately released. Now the reason why the writer order is important is that actually I will just kick that off again. Let's just do that, and then we'll see that running. The writer order is handy because you can see in here I've got a cold spots writer, which is this one here, and that's listed first. Now what that means is that the data is going to get written to disk here, and when we come down to the second one here, then that's going to start getting cached to memory. If we move this good locations writer up in order, so we'll wait for this to go through, then what we'll do is we'll start writing the data to disk for the good locations, and actually in this case there are far greater good locations than there are cold spots. So data that goes to the first writer will get written to disk straight away. Data that goes to the second and third and fourth writers will get cached until it's ready to be written. So the writing happens in a particular order. So ideally you want to identify the data set that is going to receive the most data and list it first in your navigator window to ensure that that data gets written to disk straight away rather than getting held in memory. So let me bring that task manager in place, and my machine is going to start to get a little bit unresponsive in a minute, but we'll see this piping through. There's nothing quite so exciting as watching a workspace run. There we go. Okay, so now you can see that we're writing data to good locations, and good locations is listed second. So this data is going to end up in memory. And it's not going to get written to disk for a good while yet. So that's why my memory is still increasing here. So I'm going to stop this now. So what we'll do is if we just quit that, there we go, is if we right click and we can move that up. So now good locations is listed first, and effectively we're writing up to good locations that'll be writing into disk first. So I'm going to save that process as is. And if we run this process now and bring our task manager into play, then as soon as it starts writing to the good locations file, the memory usage shouldn't be quite so dramatic. It should start to release a little bit of memory. We still have a problem, or several problems in the workspace, but that's going to make the RAM usage plateau a little bit more, so it's slightly more performant, although not in the best of states just yet. We'll see that shortly. So we'll let that get on with it. Whilst that's running, so let's move this out of the way for a moment. We're going to just move back to the slides for a moment. Okay, we want to start focusing our attention around some of the transformers that we've got. So where have we got our transformer usage? There we go. Is this thing starting to write to disk yet? Very close. Okay, I'm just going to hang on for a moment because I want to just see that just before I move on. Okay, so we're still getting quite a high RAM usage. It's still increasing quite rapidly, but as soon as it starts to cache these large volume of features to that good locations process, we should start to see that this levels off a little bit. There we go. So our RAM usage now is calming down, and in fact it's tipping back the other way. So it's starting to make its way downhill, thankfully. So let's just kill this process off. My machine is not as unresponsive as before, so that's always a good thing. I can do that a little bit now, so we get rid of the task manager. So we've sort of identified that we're not too bad on the readers. We're now a little bit better off on the writers. So we could need to consider what transformers we're using in the middle and how we're using them. And quite a few transformers now have much more or a greater number of special skills than they used to have. And that's because over the last couple of years, SAFE have been adding parameters to some of the heavy lifting transformers, like the ones that are listed here. So you can see there's an aggregator, a dissolver, a bufferer. And those transformers mean that if you need to do grouping on your data, what that can mean is that by default you'll end up holding features in memory, and they're sometimes referred to as group-based transformers. So here's the parameter that you can make use of. It's that input is ordered by group. So if I give you an example with the aggregator, if I have a lot of different polygons and I want to group them together based on a number, so an ID, and if I pass to the aggregator a feature that has an ID of 1, and then I pass in a feature with an ID of 2, and then another 1, and a 2, and a 3, and a 1, and a 4, and a 1, and a 2, the aggregator has to hold all of those features in memory, because at no point can it be 100% positive that it's not going to receive another 1 or another 2. So it holds them all in memory, and when the last feature arrives, it says, oh right, okay, now I can group those features together. I'll put all the ones together, and all the ones can be released as an aggregate multi-part feature. Ideally, what I want to be able to do is, if I can say input is ordered by group, so in my data, if my source data set contains features in the order of 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, then actually, if I tell this transformer input is ordered by group, it receives 1, then 1, then 1, then a 2, and as soon as it gets the one with an ID of 2, then it can group all the ones together, release them out of memory, and start working on the groups of 2, and then the group's ID of 3, and so on. And that's much more effective. So that can be helpful if you've got a database and you can create a view that is sorted in the order that you want to do the processing, or perhaps you may even put a sorter transformer in front of the aggregator to pre-sort the data. Now, sorting is in itself a group-based operation, but it's not as heavy as carrying out an aggregation. And in a project recently, I found that sorting after an aggregation and sorting before changed the runtime to half the time of the process by doing the sort in front. So it's definitely something worth looking at. And transformers like the dissolver, the bufferer, all these heavy lifting transformers get this input is ordered by group parameter now. Other transformers, though, have their own unique skills, and the clipper and the feature merge are two such transformers, and one of which you'll see that in a bit of detail. Here's the clipper type defined as clippers first. So what this means is if you pass into this transformer all the data that is going to be used to perform the clipping boundaries, then if you send those first and then all the things that are going to be clipped, the features that are going to be clipped can immediately be clipped and released rather than held in memory until the clippers arrive. The same is true of the feature merger. You can see here it's got an option for suppliers first. So if you can pass all the supplier features into the supplier port before the requesters, then this process and the join in this case can operate much more quickly. So that's another capability to look at to see if you can get more performance from your transformers. So let's go and have a look at these processes in the workspace that we've been looking at here. So you can see in here that we have a clipper, and when we were running this, what we were finding is that the data was getting to the clipper and it was being blocked. And let's just see that again. So if we pass that through, there we go. So the data isn't getting past the clipper because these features have not yet arrived. So if we stop that process and go into the clipper and set this to clippers first, we're telling it that we're going to send the clippers first. But if we run this now without making any further adjustments, what we'll find is that in a little while, when it gets to the end of reading these, it's going to choke, and it will tell us that it hasn't received the clippers first. So it then operates and returns back to the original mode of operation. So it won't fail, it'll just not be any different to had we not bothered swapping that parameter. So what we need to do is actually make sure that the clipping boundaries arrive first, and we can do that in a similar way to how we dealt with it in the writer. We can take our Vancouver neighbourhoods and we can move them above the input CSV. And now, when we run this, what happens is that the incoming features come in from Vancouver neighbourhoods first, and then, and let's just stop that, you saw that quickly happen, I believe, the CSV data immediately made its way and started being clipped straight away. So that's a much more rapid operation. So this transformer is now not a blocker. Those features can be clipped because the 6 clipping boundaries are already waiting for the several million cell locations. So if we go back to the slides, jump over here, I guess the summary here is that the key thing with these parameters are that they're available on a lot of transformers now, so look out for them. But bear in mind that these parameters around the transformers don't always translate your process into being more quick, to running quicker. What they do, however, make a difference to is that peak memory usage that we looked at the start of the session. The peak memory usage, ideally you want to keep it as low as possible, because when you throw a lot more data at your process, then at that point it's going to make a big difference to you and allow your process to be more scalable. So that's a trick that's worth looking at. Whilst we continue with the theme of transformers, it is also important that you consider removing any unnecessary transformers from your process. What I would say is that part of this comes in time as you get used to using FME. You can see here that there is a screen grab that shows 3 branches of a workspace, and they're there to identify 3 ways in which you could do exactly the same thing. So here, for example, there is a zone dataset, and somebody's placed, and this is a tester transformer that's been placed on the canvas, and we're choosing to test to see if there are any small zones, and what we're going to do here is pass those through and then set them to a particular value. Anything that fails, we're going to test to see if it's medium and set it to a value. Large ones, they get set to a value, and anything that is something other than large, medium or small gets set to another value. Well, you could use the test filter to do the same thing. So we've gone from having 4, 5, 6, 7 transformers to having 5. And you could also use an attribute value mapper that says, well, if it's a small feature, then set a particular attribute to a certain value. So there's an example of 3 branches that show reduced transformer use. And that comes with experience. There are many ways to do certain things in FME. Your best bet is to go and have a look at the Transformer Quick Reference Guide, and that's available on the Knowledge Center. So if you go to knowledge.safe.com, go to the documentation, dig around in there, and you'll see that there is a transformer quick reference guide that you can go and have a look at, and that's the electronic copy. If you can have a few quiet lunch times, flick your way through this document, you'll see that there are lots of references and descriptions of the transformers that are available to you, and these are a good summary of the transformers that are available. As you learn and discover more transformers, you will be able to be more efficient in your transformer use. The other thing to be aware of, though, is that you can see here that when you're iteratively building a workspace, you might find that you drop transformers on the canvas as part of testing, and then you forget about them. So here's an example. We're logging features, forcing features to go into the log, and you can see here's the details of one. Well, apart from anything, this is going to result in a larger .log file than is necessary, especially if you had changed the max features to log to something bigger than 20 features. But this information is not going to help us in this process, so we need to just get rid of it. So that's a transformer that can go and be tidied up. While we're here, we're going to move our way and consider what we could do about transformer positioning. It's often something here that you would look at after you've built a workspace, because the logic doesn't always jump out at you until you can take a step back from the process and understand what you were trying to achieve. But depending on how you've built your process in the first place, it may be necessary, or it may be possible, to go back and realize that actually in the target schema there are certain attributes that you're not using, so why don't you get rid of them? So you can go back in and add an attribute manager, or some of the earlier transformers like the attribute keeper and remover, to throw away things that aren't necessary. You might find that you haven't even used the geometry, or you used it up to a certain point, and then you write to Excel. Well, at that point, you may as well, as soon as you finish with the geometry, once you've extracted its extents or whatever you needed to do, you could go and get a transformer and use the geometry remover to throw away geometry, or perhaps just generalize it so it's less complex if you don't need the level of detail. And that means that features with less volume and less detail are going to be much more efficient to process. You might need to prepare data prior to another transformer, and I've already highlighted that perhaps sorting prior to an aggregation might improve your performance, so you can do a little bit of data preparation. But much more importantly, actually, and this is something that I often see not being done, and that's features being passed through part of a workspace that they don't need to go through. So in this case, we might be able to filter data around part of the workflow so that they aren't, there's no extra load on the process. And this is the case here. What you'll notice if you stare at this for long enough is that what we're doing is we're reading in a neighborhood name, and the purpose of the clipper is to join the neighborhood name onto the features that pass through here. But in the target schema, our cold spots data is the only one that is receiving the neighborhood name, this value here. So you can see it's been manually mapped across to the target. So it's not going to here, so we don't actually need to pass the good locations through the clipper. So what we'll do is just put the clipper in a slightly different place. So if we move it over here, and we basically take that data and point it there. And don't worry, we have broken the neighborhood name, but we'll resolve that in a moment because it's much more efficient to do it another way. So now all of these failed features, of which there are a lot, don't need to go through that clipping process. So that hopefully should be much more performant for our process. So we also need to fix this problem. So what we also talked about there is attributes, and only keeping the ones that we need. So because we're using FME 2016, what I'm going to do right up front is add in an attribute manager transformer. There's the attribute manager. And the attribute manager, I'm going to make sure I keep the neighbourhood name only. So in order to do this nice and efficiently, I can select the one I want, push it up, then select all of these, and I'm going to choose, so I did a shift select there, choose the fact that I want to remove those, and I'm going to rename this one because it needs to match up to the target. So if I just swap that to neighbourhood, you see it changes to a rename, and that option there should go nice and green now, hopefully. There we go, it hooks up. So now I'm only keeping the neighbourhood, and if I go over here, I only want station ID, power and quality to join on, so go on, get another attribute manager, we'll drop that in place. And the same deal, I will take station ID, power and quality, move them up to the top, grab everything else, choose to remove them, and now we've only kept what we need. So hopefully what that means is that that process should be a little bit more performant now. What I'll do is, whilst we're going, is I'll run that now. We should see that immediately features start to make their way through the process. And there you can see a few features need to go through and to be assessed in the cold spots. So we'll let that run for a while. So here just is a reminder about the attribution. That attribute manager is new to FME 2016. It does replace a lot of transformers you might have used before, some of those shown on the slide in the background there. It doesn't deprecate them, they're still available, but the attribute manager includes a lot of their capabilities. And if you've been on any of the recent FME 2016 World Tour events, you'll have found out a lot more detail about the attribute manager as that new transformer. The key thing really is, if you don't need an attribute, get rid of it as soon as possible, because that's going to carry extra load through every transformer that is unnecessary. So let's have a look at this workspace. It should still be running. It does now take a lot less time than it did before. What I'll do is, if I tuck that over onto one side of the screen there, so that you can see it going. And I just want to highlight some stats. So just those tweaks that we made, and there's no smoke and mirrors here. This is a genuine performance runtime. When I ran this process previously, it took 42 minutes, 48.7 seconds. The CPU time was 7 minutes, and it basically consumed very nearly 10 gig of RAM on my machine. I don't have 10 gig of RAM, so clearly some of that was coming from virtual memory, because other applications would have been consuming some of the real RAM as well. And at the end of processing at the end of making those tweaks that we've done, the result is identical. It's just that it runs in 2 minutes. And you'll notice that the key thing here is that the CPU time is now 2 minutes. So it runs in 2.5 minutes. I'm only losing 30 seconds of CPU time in the actual process. So it's much more efficient, clearly using all of the resources that are available. It's processing the data efficiently. One further thing I might be able to do to get a bit more performance here is to work with reading and writing to and from a solid state drive. That may give me a bit more performance on the input-output to the process, as well as if any memory is needed to be used or cached to disk, it would help me there. And you can see the key thing here is, and this is the biggest deal really, is that my peak memory usage is super tiny in comparison to what it was, which means that I could throw ever-increasing amounts of data at this process and be reasonably relaxed that no matter how much data I tried to put through this process, it would still keep running and give me the answer that I needed at the end of the process. So that's where we're at. I'm actually going to let that run to completion because I want you to see that. I'm just going to nudge this over to the other side of the screen because I want to expose the machine that I'm running this on. just so that if you want to do any benchmarking of your own, you can see that machine details. So it's I guess, oh, there we go. Okay, so the process is just finishing off. I'll let that pop up. There we go. So it's completed. So it's just under 4 minutes on this run, and you can see that we've got a peak memory usage. It's pretty small in comparison to what it was. And if I just zoom in, you see the volume of features there. 1.5 million have been processed through to good locations. This machine is no slouch, but it is pushing it for age now. It's a few years old, but it's got a reasonable bit of hardware on it. 64-bit FME on a 64-bit operating system in the case, Windows 7. So hopefully, using some of these tips, you can be a little bit more excellent with your use of FME, and we want you to take some of these tips and hopefully apply those to your processes. A few places for you to go and have a look at more resources. You can go to safe.com. You can also go to onespatial.com/FME. That's our page. OneSpatial Group is our YouTube channel where you'll see some of these previous webinars that I was referring to at the start of the day, the start of the session. You're welcome to go and have a look there. This webinar will be posted up to that channel at some point soon, so check back if you want to go and listen to any of this session again. And do go to knowledge.safe.com. There are a lot of articles around performance management and tweaking your workspaces, so definitely the place to start for tips and tricks. We also deliver quite a lot of training in person, so this is part of what we've been looking at today is covered on the advanced course, the advanced FME course in a bit more detail. So we'd love to receive you either at our training venue in Cambridge in person, or we can come to you and we'll travel all over to deliver our training courses. If I just dive over to our website, you can see here that we deliver a number of FME courses, so both FME Desktop, Desktop Advanced, and also server authoring training. Those are public courses listed in our offices in Cambridge, or as I say, we can organise a bespoke training course for you at your offices. But for now, I'm going to finish up there, and thank you all very much for attending. We do have a few questions that appear to have come in on our chat window, so I'm just going to stare at those for a moment, and I will hang on the line to give you the answer to those if I can. But for now, that's the end of this formal session. So thank you very much, and please go to onespatial.com and go and have a look at our events page and register for any of our forthcoming sessions. Thank you very much.